Audio classification involves categorizing audio clips based on their inherent content. Essentially, it's about pinpointing the nature or theme of an audio snippet. It's important to emphasize that many times these models are trained on a precise set of labels. This equates to them being fine-tuned to identify and sort audios into these particular categories. For our demonstration today, we are using a model that's adeptly trained to tell apart male from female voices. Let's delve into a hands-on example. We will start with an audio file, which is a brief snippet of someone talking. We process this audio through a specific model named, this is the long name of the model, which has been expertly trained to distinguish gender in voices. The results are quite telling. The model confidently asserts with 99.8% assurance that the voice in this audio is male. Conversely, it attributes a mere 0.19% probability to the chance of the voice being female. First things first, we import the necessary library. Within this library, there is a function named pipeline. Think of this function as a bridge. It simplifies and encapsulates the underlying complexities for us. This makes our tasks more straightforward. Next, we set up our audio classifier. To do this, we use the pipeline function we just talked about. We specify two things: the type of the task, in this case audio classification, and the model we wish to use. For this demonstration, we are using this model, which is designed specifically to distinguish between male and female voices. With our classifier ready, we proceed to the exciting part, classifying our audio. Here we make a call using our classifier and provide it with an audio URL. This instructs the model to process the audio and determine its category. Once processed, our model returns result in a structured format. For our example, it's evident. The model is highly confident with a 99.8% score that the audio clip contains a male voice. In contrast, it believes there is a minimal 0.19% chance of it being a female voice. These scores allow us to understand the model's level of certainty for its classifications. If you have an audio file on your computer and it is not online, you can still use it. First, we turn the audio file into a special link using url.createObjectURL of the file. This gives us a special link that our program can read. After we get this link, we pass it to our classifier. Let's come to the implementation. In our main page, if you go to the audio category, you will find audio classification. That opens the audio classification page. Then if we go to Visual Studio Code, we can open the audio classification page. So first, as usual, we create the script tag. We create it of type module because we want to use the import statement inside it. Then that's what we actually do. We import the pipeline function from the Transformers.js library. Now we get this Transformers.js library from the website. So if we go to Transformers.js installation, if you look here, we have this. Of course, here the version is 2.6. I use 2.58 because I want to be a little bit back on the version. Okay, let's go back to Visual Studio Code, and the next step will be to attach the pipeline function to the Windows object. This is because in scripts of type module, objects are local. To make them available globally, we need to attach them to the window object. Okay, let's go down. Here in the initialized model, we will actually fire our pipeline function. We pass it the task type, which is audio classification, and we also pass it the model. Now we get the model from the same page. So if we go to Transformers, the pipeline API. If we go below, audio classification, this is audio classifications. Here we can see model. Our model will be one of these. Okay, then we do the normal. First we get the URL by getting the text input and getting its value, and store this in text field value. This is the URL. Then we fire the classifier, we give it the URL. Of course, it takes time. That's why we use the await keyword. And in order to be able to use the await keyword, we should have this done as async. Now, after time, it will return the result. We will convert it to string and output it in the output area. Let's now test that. Okay, so it came back to us saying that it is male and it's sure 0.998. Of course, the closer to the one is the most confident. So it is fairly confident that it is a male. And just to remind you with the audio, let me play it for you.
And so, my fellow Americans, ask not what your country can do for you, ask what you can do for your country.
Okay, now then let's use a local file instead of a URL on the internet. So in this case, the first step is we get the file input. After getting the file input, we obtain the selected file, in which in our case we only support one file selected. Then we check if there is a file selected or not. If no file is selected, we will alert and return. Then we create a URL from this file by using the URL.createObject URL of the file. That returns a URL for us. Now we use this URL in order to fire the classifier. Of course, this takes time. That's why it is await. When it finishes, it will return the result in the result object. We will convert here the result object to string and output it in the output area. Let's go and test this. So here we will choose the file. It is this file, classify. Okay, so as you can see, again, it returned that it is a male with a very high confidence. So that's about image audio classification.